this video we're going to look at the y-intercept of a straight line. Now the y-intercept of a straight line is the y-coordinate of the point where the line crosses the y-axis. So any straight line on a set of axes will cut the y-axis at some point, and we call that point, well, we call the y-coordinate of that point the y-intercept. A few things to note. The y-intercept is often denoted by the letter C. No one's really sure why, but the letter C is the most common letter used to denote the y-intercept. We only care about the y-coordinate, so the reason that the y-intercept is just the y-coordinate of this point is that the x-coordinate will always be 0, since if we're on the y-axis, then the point must have x-coordinate 0, because we haven't moved any direction along the x-axis. Let's look at a few examples of straight lines. So we can see both of these are cutting the y-axis. This one here at this red dot, and this second one down here. Well, the coordinates of these dots each have x coordinate 0, since we haven't moved at all along the x-axis. We've just moved up the y-axis to get to here, and down the y-axis to get to here. So let's look at an example. What is the y-intercept of y equals x minus 2? So hopefully you recognize y equals x minus 2 as a straight line equation. We want to know what the y-intercept is. Well, we'll start by just drawing the line to get an idea of what it looks like. Our sketch might even suggest what the y-intercept is. So let's plot a couple points that are on the line. So when x equals minus 3, we plug that into our equation and we get minus 3 minus 2. So y is minus 5. So minus 3 minus 5 is a point on the line. So let's plot this on our axes. It's down here. When x equals 3, we plug this into our equation and y equals 3 minus 2, which is 1. So 3, 1 is also on the line, which is here. So we can plot the line as we've seen in previous videos by simply drawing a line through these 2 points. So that's our line, but we want to know what the y-intercept is. Well, looking at our diagram, it looks like it should be minus 2. This point here, it looks, you can see, to be cutting at minus 2, but we need to prove this mathematically. So what do? Well, as we said, the x-coordinate of the point where the line cuts the y-axis is always 0. So if you want to find the y-intercept, you just plug x equals 0 into the equation to find what y is, and there you have the y-intercept. So, well, when we plug x equals 0 in, we just get minus 2, because we get 0 minus 2. So y is minus 2. So that's our y-intercept. And as I said, we often label this C, so I'm going to say C, in this case, is minus 2. Now, it's worth noting something quite important. If we look at our equation, the constant being subtracted on the right-hand side is minus 2, and this was indeed our y-intercept. And this is no coincidence, this will in fact always be the case. Let's look at why that is. So, say we have a general line, y equals ax plus b. This is just the general equation of a straight line. Then, to find the y-intercept, we would plug in x equals 0, as we just did. And what would happen? We'd get y equals a times 0 plus b. But a times 0 is just 0, so this term disappears, and we get b. So, at x equals 0, y equals b, the constant term that we're adding on. Hence, this is always going to be the y-intercept. We'll make one final point, and this is a very important point. The equation for a straight line is usually denoted y equals mx plus c. We've been using ax plus b in these videos to show a general equation, but the most common way of writing the general equation for a straight line is y equals mx plus c. We use c because we know that that number is the y-intercept, and we often use c to denote the y-intercept. The reason the number in front of the x is m is something we will explore in the next video in this series.
The great river. running silver through the night.